In this video, I'm going to show you how many light rays from the object is refracted by the converging lens to form the sharp image. Now, there's a purpose for understanding this because it helps you explain why, when part of the lens is covered, a sharp image is still formed, but there are some changes to the image. Now, in an earlier video, as I mentioned, these three rays which I've drawn are the three basic light rays. There are many rays that pass through the converging lens, and I'm going to illustrate to you now what the other light rays are. Now, for these three basic rays, one is from object to the lens, the other is from the lens through the principal focus, and the other is from the object through the optical center. The other light rays, example, one of the light ray is not parallel to the principal focus. As you can see by the brown line which I've drawn, okay, this is an example of one of the light rays. Now, what happens when the light ray strikes the converging lens? How do you know how much it will refract? How do we know how much it will refract? Now, when it comes to this, you just remember in the earlier video, I did mention you only need 3 light rays to locate the position of the sharp image. So any other light rays that you draw from the object to the converging lens, the light ray is refracted from the converging lens to the image. So all you have to draw is from the converging lens to the image. Okay, as you can see, it's not easy trying to draw with a tablet, but I'll try what I can. So bear in mind, if the initial ray from the object to the lens is not parallel to the principal axis, please do not pass the light ray that comes from the lens through the principal focus. Do not do that. Just draw the light ray directly from the lens to the image. Another example of a light ray. Now let's say this light ray I've drawn. How will it look like when it gets refracted by the lens? You just draw from the lens to the image. So all the while we have been drawing light rays above the principal axis. How about the light rays below the principal axis? What does it look like? Now I'm going to draw another light ray like this. And what happens when it gets refracted by the converging lens? It passes through, you just draw the light ray from the converging lens to the image. And I'm just going to draw one final ray to illustrate my point. So now you have many rays passing from the object, you have many rays reflected by the object through the converging lens to the image, to the position of the image. Now, one way to one way to understand this diagram is to look at it from this point of view. Right, you can see many light rays okay. So this means the image is bright. The image is bright, right? Many light rays, okay? The image is bright. So now the question is, what happens if I cover part of the lens? I'll just illustrate here. Right, so if part of the lens has been covered by the red marking which I've illustrated on the screen, as you can see, when the light ray strikes the covered part of the lens, it's not able to pass through the lens anymore. Light ray is not able to pass through the lens. So from this illustration, less light has now converged onto the sharp image. So which means, since there are less light, so that means the image will be less bright. Or should I say the image will be dimmer. So when part of the lens is covered, less light is refracted through the lens. There is less light converging on the sharp image. Therefore, the image is dimmer. As I mentioned in the earlier video, the image can be formed anywhere, but it's just that whether the image is sharp or not. So the convergence of the light rays at this particular point showed that the image is sharp. But when there's less light converging on the sharp image, right now the image has become dimmer. So what happens if I were to cover half the lens? What will I see? Okay, let me erase the unnecessary part first. So what happens if half the lens is covered? So what I've done here is I covered the bottom half of the lens. So the minute the bottom half of the lens has been covered, as you can see here, all the light rays at the bottom half of the lens, all the light rays that strikes the bottom half of the lens is not able to pass through the lens anymore. So from this diagram, you can see that less light has converged at the position where the sharp image is. And because less light has converged onto where the position has converged onto the position of where the sharp image is. So the image has become even dimmer. But because half the lens is covered, when half the lens is covered, only half the light rays is refracted through the lens. As such, the image is now half as bright. Why I show you this is because there's this misconception here that when you cover half the lens, the image will become half. Well, that's not true. As you can see in this diagram, the image did not become half. It doesn't affect the size of the image, right? What happens is less light passed through and the position of the image did not change, so the image just becomes less bright. There's also another misconception that when half the lens is covered, the image becomes blur. Now, the image becomes blur if you have moved the screen where the image is formed. You move the screen either towards the lens or away from the lens. So the covering half the lens doesn't affect the sharpness of the image. As you can see here, again, just less light rays have passed through, so the image is now, since half the lens is covered, the image is now half as bright.